everyone, my name is Cole, and today we will be going over quadratic functions. So a quadratic function is a function that has a highest degree of x of 2. So for example, x squared plus 3x plus 6 is equal to 1. This is quadratic because we have this x squared here, which means that as we increase x, y is going to increase in a nonlinear fashion. There's going to be different steps of y as we increase x. And quadratic functions, we can't solve them the same way that we solve linear functions, because if we try to isolate the variable, we suddenly have like x squared plus 3x is equal to negative 5. And what do we do from here? Well, we can't divide by 3 because 3 is not a factor of both x squared and 3x. And we can divide by x, but then it leaves us with a negative 5 divided by x on the other side. That's an x to the negative 1. So there's not a way to solve this efficiently by isolating the variable. So we have to do something else. And there are 3 methods to solve quadratic functions. The first one is factoring. Factoring. So factoring a quadratic function means putting it in the form x plus something times x plus something equals 0. Now this equal to 0 is really important when we're solving quadratic functions, because if you look at a quadratic function graphed on a coordinate plane, we have these 2 zeros. These are the x-intercepts. That's when y is equal to 0. And we can find those and solve for when y is equal to 0 by setting our equation equal to 0. So the standard form of a quadratic is y is equal to ax squared plus bx plus c, where a, b, and c are coefficients and x and y are variables. We can factor when and only when, or if and only if, a is equal to 1. And why is that? Well, it's not exactly true. We can factor for any value of a, but the way that I'm going to teach you to factor here, where we find something that multiplies to c and adds to b, is only true when a is equal to 1. Because if we FOIL out this multiplication here, do this on this side, we get x times x. So the only x squared term we're going to get has a coefficient of 1. So the reason that this is helpful is because if we have something times something equal to 0, ab equals 0, common sense says that one of those terms itself has to be 0. And the reason for that is because we can't multiply any positive or negative, basically non-zero integers together to get anything that is 0, right? 1 times 1 is 1. 3 times 5 is 15. The only way for something to be 0 is if we have like 3 times 0 or 0 times 0. So one or both of them has to be 0. Which one is 0? Well, the answer is both, because we're solving for every single possible value of x, right? If we look back at the graph here, we have 2 values, 2 zeros, that satisfy this equation. So both of them are correct. It's not that the graph like reaches 1, 0 or the other 0. It's that the graph reaches 1, 0 at one x value or one y value, and then moves along the graph and it reaches the other 0. 0 being another term for root. Okay, so let's learn how to factor. Say we have x squared plus, what's a good one? 4x plus 4 equal to 0. How can we factor this? Well, we have to find something where when we put it into the form x plus, I'm going to call the roots r1 and r2, x plus r1 times x plus r2 equals 0, that when we expand out this multiplication, it should be equal to x squared plus 4x plus 4. So let's expand out this multiplication. We're going to use FOIL, which stands for first, outer, inner, and last. And we're going to multiply x times x that's first, x times r2, outer, r1 times x, inner, and r1 times r2, last. And what we get is x times x, or x squared, plus x times r2, so r2x, plus r1x, that's the inner, plus r1, r2. I'm going to simplify this just a little bit further. I'm going to combine like terms because both r2x and r1x have a factor of x. So I can combine them and I can say this is equal to x squared plus r1 plus r2 x plus r1, r2. So we can see here that we have some conditions now. We have some equations. Our conditions are, let me not use yellow. Our conditions are r1 plus r2 has to be equal to 4, right? Because if this is equal to that, then this has to be equal to that. So r1 plus r2 is equal to 4. And also r1 times r2 is equal to 4 as well. In other words, because this is in the form ax squared plus bx plus c equals 0, we have to find something, find two numbers that add to b and multiply to c. So for this example, you might be able to do it in your head. You might be able to look at this. Oh my god, krilling my shelf. Sorry. Yes. Command shift. How do I do this? Where is it? Rejoin. Hell yeah, I'm back. Cool. So you might be... I'll cut it out. It's okay. You might be able to do this one in your head. You might be able to say that I need to find something that adds to 4 and multiplies to 4, and those two numbers are 2 and 2. But if there might not be, like, you might come across an example that's not as easy as this. So we should be able to find a way to do this that's more accurate and more reliable. And the way we're going to do that is by using C. Because C means that R1 times R2 has to be equal to C. So when we think of R1 plus R2 being equal to B, it's a little bit more ambiguous because you can add an infinite number of things together to get any number, right? I could say 1 plus 1 equals 2, but I could also say negative 1 plus 3 equals 2, and I could say negative 1 million plus 1 million and 2 equals 2. So you can go an infinite number of directions with sums. But products are a little different. Numbers have something called factors. And factors are numbers that can multiply to get a certain number. Really big numbers, like 1 million, have a lot of factors. But smaller numbers, like what you're going to see on the SAT, have fewer factors. So what are the factors of 4? Factors of 4. Well, I like to start out with 1. Because 1 goes into everything. You can multiply 1 by the number you're looking for to get that number. So I'm going to put that in the middle here. 1 times 4 equals 4. I'm going to argue that negative 1 is also a factor. Why? Because negative 1 times negative 4 is equal to 4. How about 2? Does 2 go into 4? Well, it does. 2 times 2 is equal to 4. And how about 3? 3 can't be multiplied by a whole number to get 4, so I'm going to cross out 3. Now I'm going to get to 4. 4 times 1 equals 4. But 4 times 1 equaling to 4 is the same thing as 1 times 4 equaling to 4. So I've looped back around myself, and this is when I know that I've gone through all the factors. I'm going to keep going the other way. Negative 2 times negative 2 is equal to 4. And that's all of the factors, because then I get to negative 3, and that doesn't go into 4, and then negative 4 times negative 1 is the same thing as negative 1 times negative 4. So these are my factors of 4. And you can make a list for any number at all by doing this, by starting at 1, then going to 2, 3, 4, 5, 6, and just seeing, does it go into this number? And it's going to be a little intimidating if you have like bigger numbers, but remember that on the SAT, with the new SAT, you're going to always have a calculator with you. So even if you have to do like a complicated division, you can do that in about 4 seconds on your calculator. So you shouldn't stress out about finding factors of things. Now all we need to do is figure out, are there 2 numbers in this list of factors that both multiply to 4? We know that's true. That's how we made this list of factors, but also adds to 4. We're going to start with -2 and -2. -2 plus -2 is -4. That's not what we want. We want +4. So that one's not right. -1 plus -4 is -5. So that one's not right. 1 plus 4 is 5. So that one's not right. But 2 plus 2, that is equal to 4. So these are our R1 and R2. We found our R1 and R2 values. I'm going to write them down here. We have x plus 2 times x plus 2 is equal to 0. But we still need to solve. So this is something that you can get stuck on. You can say, well, my roots, my R1 and R2, were +2 and +2. So those must also be the zeros of my function, +2 and +2. But that's not the case, because remember, if we multiply 2 things together, this is our A and this is our B, at least one of them has to be 0. But if x plus 2 equals 0, then x is not 2. And x is what we're solving for. X is equal to -2, because we have to move this 2 over to the other side. So once you find your R1 and R2, your actual roots are going to be -R1 and -R2. And so this problem has one root. X is equal to -2. What does it mean for a parabola to have one root? Well, it means that it only touches the x-axis in one place. And the only way that it can do that is if it's tangent to the x-axis. So for example, a parabola like this, or a parabola like this, something that touches at one point. So we're going to do one more example with factoring. Something maybe a little more complicated. For example, x squared plus 9x plus 14 is equal to 0. So I need to find something. Find R1 and R2 such that R1 plus R2 equals B, which is 9, and R1 times R2 equals 14. So let's list our factors of 14. I'm going to start with 1. 1 times 7 equals 14. I'm going to go to 2. 2 times... Oh, I'm so sorry. 1 times 14 equals 14. LOL. 1 times 14 equals 14. 2 times 7 equals 14. 3 doesn't go into 14, so I'm going to skip that one. 4 also doesn't go into 14. We go 4, 8, 12, and then 16. Likewise, 5 goes into 15, not 14. 6, 12, 18. 6 doesn't go into 14. 7 goes into 14. 7 times 2 is 14. But 7 times 2 is the same thing as 2 times 7. So I'm done with the positive factors. So you can see that even though 14 is a bigger number than 4, 4 actually has more factors than 14. So it's not always going to be that bigger numbers have more factors, so you don't always have to be scared of making these factor lists. We can go to negative numbers now. -1 times -14 is 14, and -2 times -7 is 14. These are my 4 factors of 14. Do any of these add to 9? I think so. I think 2 plus 7 equals 9. So I can write my equation as x plus 2 times x plus 7 equals 0. In other words, x plus 2 equals 0, or actually, and x plus 7 equals 0, because we're solving for every single possible value of x. In other words, x equals -2 and -7. And that's the answer to this problem. So that's how to factor. And factoring is really helpful because it's actually the fastest way to solve a quadratic function. If you get a nice quadratic function like this one up here that has a b value and a c value such that you can find an r1 and r2 that adds to b and multiplies to c, then factoring is like really, really quick. And you get better and better at factoring the more and more you do it, and you start noticing patterns of things that add and multiply to different numbers. However, you're not always going to be able to factor. Imagine that you have something like this. X squared plus 6x plus 3 equals 0. Well, it looks like you might be able to factor this. It's in the form ax squared plus bx plus c is equal to 0, and a is equal to 1. But when I list the factors of 3, I get 1 times 3 and -1 times -3. Those are the only factors of 3. And neither one of those add to 6. So we actually can't do this by factoring, but we can do it by something else. We can complete the square. And completing the square is basically a recognition of the fact that even if a quadratic isn't set to 0, if a quadratic is something called a perfect square, in other words, if it's in the form x plus r1 squared equal to any number, we can actually still solve this. Because even though we don't have that powerful 0 that allows us to say that one of these or both of these factors must be 0, we have this square. And this square around our entire term is extraordinarily powerful as well, because it means we can take the square root of both sides, like this. You can do that because the square root's just a function. And as long as you do the same thing to one side as the other side, your equation is still true. So I can take the square root of both sides, and when I take the square root of x plus r1 squared, I'm taking the square root of something squared. So it's just that thing. Just like the square root of 9 squared is the square root of 81, which is just 9. So when I take the square root, I get x plus r1 is equal to plus or minus root d. Now, why did I put that plus or minus there? The reason I put that plus or minus there is because I actually know nothing about the sign of x plus r1. Because x plus r1 is squared inside the parentheses, inside the root. And anything squared is gonna be positive. So if, for example, x plus r1 squared was equal to 9, x plus r1 could be equal to 3. But x plus r1 could also be equal to -3. Because just as 3 times 3 is 9, -3 times -3 is also 9. Because two negatives in math make a positive. So now we have a linear equation. That's really cool. We just went from a quadratic to a linear. We don't have a squared x anymore, and we can just move this r1 over to the other side. X is equal to -r1 plus or minus root d. So basically what I'm saying is if we can get this equation into this form, into the form x plus r1 squared is equal to d, we can solve it even if it's not set equal to 0. And because it doesn't need to be set equal to 0, we can do that. There are steps to completing the square. The first step is to move c to the other side. So we're going to get, if we use our example from up here, which is x squared, I'll write it down here so we can see it, x squared plus 6x plus 3 equals 0. When we move 3 to the other side, we get x squared plus 6x is equal to negative 3. Step number 2 is add b over 2 squared to both sides. Both sides. This is really important. If you don't remember to add it to both sides, you've broken your equation. Because if x squared plus 6x is equal to negative 3, x squared plus 6x plus something else is certainly not equal to negative 3, unless that something else is 0. So b squared over 2 is, b over 2 squared is 6 over 2 squared, which is equal to 3 squared, which is equal to 9. So I'm going to add 9 to both sides. I get x squared plus 6x plus 9 is negative 3 plus 9, which is positive 6. Step 3 is to factor. And now we can factor. We can factor this as a perfect square. We are going to factor it as x plus b over 2 all squared. And you can do this on your own. You can go ahead and take x plus b over 2, which is 3, squared, and you can FOIL it out, and you can prove that it's equal to x squared plus 6x plus 9. And this is equal to 6. And step 4 is just to solve. So x plus 3 is plus or minus root 6, and x is 3 plus or minus root 6. This is an irrational answer, because the square root of 6 is some big decimal between 2 and 3, 2 point something. So we can leave this in this form. This is a completely acceptable form to leave your square root in, your answer in when you're completing the square. So let's do another example with completing the square really quickly. If we have x squared plus 18x minus 7d2, yeah, that's fine, equals 14. This example is a little different because this is not set equal to 0. But it's okay, let's not panic, because if we move this 14 over to this side, it suddenly is set equal to 0. So it is still a quadratic, it's just not in standard form. But we don't even need to move that 14 over to that side because we're completing the square. So the first step is going to be moving all the constants over to the right side of the equation anyway. So instead of moving the 14 over to the 72, I'm going to move the 72 over to the 14. And I'm going to get x squared plus 18x is equal to 14 plus 72, which is 86. Now I'm going to figure out what I need to add to both sides. Remember, it's b over 2 squared. So that's 18 over 2 squared, which is 9 squared, which is 81. So I'm going to get x squared plus 18x plus 81 is equal to 86 plus 81, which is 167. Now I can factor it as x plus b over 2 squared. X plus 9 squared is plus or minus the square root of 167. And I can take the square root, or pardon me, I did the square root much too soon. Let me factor it first. Is equal to 167, got ahead of myself there. Now I'm going to take the square root of both sides. And I'm going to get x plus 9 is equal to plus or minus the square root of 167. That plus or minus is very important. You're going to keep having to use that plus or minus all throughout your entire career. I am going into my third year of undergrad as a physics major, and I lost points. I lost 2 points on my modern physics first exam for not using a plus or minus on my square root. So it will stay with you for your entire life, and we're learning it here. So learn it well. Now we're going to move the 9 over to the other side, and I'm going to get finally x is equal to negative 9 plus or minus the square root of 167. And that's the answer. So throughout this entire video, I've kind of brushed over it a little bit, but I'm going to revisit it now. In order to complete the square, your coefficient of x squared, your a, has to be 1. It doesn't work if it's not. Same thing with factoring. But what if your coefficient of x squared isn't 1? What if you have, for example, 3x squared plus 5x minus 7 equals 0? What do I do now? I can't divide by 3 because, well, I mean, I could. But if I divided by 3, I would have 5 over 3 as my b. And if I then had to find 5 over 3 over 2 squared, it would get really messy. So surely there's something else we can do. And there is. There's the quadratic formula. The quadratic formula always works. It's this like blanket way to solve a quadratic equation. You may have heard a song associated with it to the tune of Pop Goes the Weasel. It is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm not going to sing for you. I apologize. So this is actually extraordinarily powerful, and they actually have this written on the SAT on the first page of the math section, along with the area of a triangle and the area of a circle and other things like that. So you don't have to necessarily worry about memorizing this for the SAT, but I would also recommend that you memorize this. Look up the song if it helps you, because the quadratic formula is going to be something that you're going to actually use quite a lot in the future. And it is helpful to have that memorized. So this is a formula. So we're just going to plug and chug here. We're just going to plug things in. X is equal to negative b. B is 5, so that's negative 5. Plus or minus the square root of 5 squared minus 4 times a, which is 3, times c, which is negative 7, all over 2 times a, which is 2 times 6. 2 times 3, which is 6. So this is negative 5. I'm going to clean this up a little bit. Plus or minus the square root of 25 plus 4 times 3 is 12. 12 times 7 is 84. So 25 plus 84 is under the root, and 6 is in the denominator. So this is negative 5 over 6 plus or minus root 109 over 6. And it's as simple as that. It's as simple as plugging things into the quadratic formula. We can do one more example with this. X squared, let's do negative 3x squared plus 7x minus 10 is equal to 0. We get x is equal to negative b, so negative 7, plus or minus the square root of negative 7 squared, or actually, yep, positive 7 squared, because it's b squared, plus or minus 4, let me mess this up. Good thing to do is write out the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's reference it there, since I clearly can't remember it. Negative 7 plus or minus the square root of b squared minus 4 times negative 3 times negative 10 ac all over 2 times negative 3. So x is equal to negative 7 plus or minus the square root of, this is 49, minus 120, all over negative 6. So x is equal to negative, or the negative undoes the negative, so this is just 7 over 6, plus or minus the square root of 49 minus 120 is going to be, Lord, 100 minus 20 minus 29, 80, 71, negative 71 over negative 6. And this is the answer. But I do want to point something out with this answer, which is that we have this negative under the root. And your instincts should be going off and telling you that something's wrong here, because you shouldn't be able to have a negative under a root. Because we've been taught that a negative times a negative is a positive, and a positive times a positive is a positive, so squares should always be positive. So what does it mean to take the square root of a negative number? Well, it means that that number is imaginary. You may have seen the letter I, like a squiggly I like that, used for an imaginary number. And that's what this means. This means this parabola still has roots. Its roots are just not on the Cartesian coordinate plane. So if I drew this parabola, it might look like this. Just completely missing the x-axis entirely. Just completely above or below it. But if I plotted this on the imaginary plane, which has I on the y-axis instead of y, it would cross the x-axis. So we can go into philosophy and talk about what it actually means to be an imaginary number, but I'm not going to do that, partially because I don't really understand and partially because it doesn't really matter. You can write this as 7 over 6 plus or minus root 71i over negative 6. And both of these answers are valid and correct. So those are the three ways to solve a quadratic function. You can factor, you can complete the square, or you can use the quadratic formula. When in doubt, plug it into the quadratic formula, because quadratic formula will work for the ones that you could factor or complete the square for. It's just a little bit longer and more tedious, and there's a bit more simplification involved in which you could make mathematical errors. But I hope this helped, and I will not see you next time because this is not a series. And shift 5.